At present, nearly 1/3 of the conduit rack platforms in China's offshore have exceeded, or will soon reach the design life. The demand for platform structure maintenance or repair and life extension is more urgent than ever. The traditional underwater structural damage detection of the conduit racks, fewer measurement points, difficult, high cost, and unable to predict the state of the platform structure. The conduit rack platform is mainly composed of conduit racks, conduit rack caps, piles, decks, and deck modules. Fiber optic grating sensors are mainly installed on the pile legs, pile boots, and support rods to conduct real-time monitoring, according to the offshore wind and wave environment, monitoring and platform structure temperature, vibration, and strain response. The fiber grating sensor consists of multiple inductive sensors connected in series, using low-loss photosensitive optical fiber. In the drawing process, the bare fiber is exposed before coating, and hundreds or thousands of weak gratings are written in one fiber to form a fiber grating array. For the monitoring of the underwater part of the platform, a single column in the same horizontal direction to install 4 groups of sensors. Vertical direction in the key stress position installation, or equidistant multi-point high-density installation. The first installation of the sensor base. The base is fixed by the limit plate. Welded to the column, or the base welded to complete the removal of the limit plate. The installation of FBG strain sensors, the clamping plate vertically put down 2 sensors. Fixed each sensors in the welded base. 8 columns in the same way, all installed sensors. Each fiber optic all connected to the central control room. When the laser pulse propagates along the fiber in the forward direction, it is partially reflected by the fiber grating sensor array connected in series on the fiber, and the reflected light returns to the demodulation module along the same fiber in the backward direction, which is processed by the underlying algorithms and then detected and analyzed in real time, which is the best way to ensure that the conduit rack platforms will be in service for a long period of time. With the marine environment, changes in stress points, biological erosion and seawater corrosion, etc., may make the structural strength of the main load-bearing components of the conduit rack changes. Over time, these places will be hidden safety hazards. The use of optical fibers in the optical parameters such as light intensity, frequency, wavelength, phase, and polarization state with the change of the external parameters to be measured. Changes in the optical fiber parameters to achieve the purpose of detection of the external measured physical quantities. By detecting the changes in the optical parameters in the fiber, the purpose of detecting the measured physical quantities in the outside world can be achieved. When the laser pulse propagates along the fiber in the forward direction, it is partially reflected by the deformation of the ultra-weak grating sensor array connected in series on the fiber, and the reflected light returns to the acquisition host along the same fiber in the backward direction to be detected and analyzed in real time. And through the wavelength change of the reflected light back, we can also determine the actual amount of strain, temperature change, and the sensor position, so as to realize the real-time monitoring of the body to be detected. At the same time can also support multiple sensors, a full range of detection platform work safety. Fiber optic grating detection sensors can also be used in large bridge slopes, large-scale water conservancy projects, large-scale equipment, coal mines, petroleum and petrochemical tunnels and transportation, intelligent building perimeter security, high-speed railroad disaster prevention systems, and other applications.